So, have you ever been writing some Python and just wished you could force your classes to follow a specific set of rules? Well, today, we're diving into a super powerful feature that does exactly that. Abstract Base Classes, or ABCs for short. Seriously, this is the key to creating a clear, enforceable blueprint for your objects, and it can totally change how you design your code.
Here's what we're going to cover. First, we'll talk about a common coding problem that I bet you've run into before. Then, we'll introduce the official solution, the abstract class. And what's really cool is you're already using them, so we'll pull back the curtain and see where they're hiding. After that, we're going to get our hands dirty and build our own custom container with a performance superpower. And finally, we'll wrap it all up with a key takeaway you can use in your own projects right away.
All right, let's kick things off with a really fundamental challenge in programming. You know, when you're building any kind of complex system, you've got all these different components that need to play nicely together. So the big question is, how do you make absolutely sure they all speak the same language and follow the same set of rules?
Okay, let's make this real. Imagine you're building a media app. You've got an MP3 player, a video player, and maybe a streaming player. Now, for your app to work smoothly, you need an absolute ironclad guarantee that every single one of those objects has a .play method. Because if one of them is missing, what happens? Your app breaks, maybe even crashes. That right there is the blueprint problem we're here to solve.
And this brings us to the really elegant, official Python solution, the Abstract Base Class. This is the tool that lets us define a contract, a non-negotiable set of rules that other classes have to follow, no exceptions.
You know, here's probably the best way to think about this. An abstract class is like an architect's blueprint. It defines the whole structure, where the walls go, how many doors there are, but you can't actually live in the blueprint itself, right? A concrete class, though, that's the finished house. It's built from the blueprint, and it's the actual tangible thing you can use and interact with.
So to put it a bit more formally, an abstract base class is a class that is intentionally left incomplete. You're not supposed to create an object from it directly. Its entire job is to be a foundation, a base that other more specific classes can build on top of to become complete, usable, concrete objects.
So how do we actually make one of these? It's surprisingly simple, actually. First, you just import the tools you need from Python's built-in ABC module. Then, you define your base class, something like our media player, and finally, you declare the methods that all its children must have, like .play. The real key here is that you don't actually write the code for the method in the blueprint. You just mark it as abstract. You're just defining the contract and leaving the nitty-gritty details to the other classes. Now, at this point, you might be thinking, this all sounds a little advanced. But here's the twist. If you have ever used a list, a dictionary, or a set in Python, and I know you have, then you've already been working with this concept every single day without even realizing it.
It all happens thanks to a module tucked away deep inside Python called collections.abc. You can think of this as the official library for all the blueprints, all the abstract base classes that define exactly how Python's most basic data structures are supposed to behave.
So yeah, your everyday list, dict, and set, they aren't just some random objects that were coded from scratch. Nope, they are the finished houses, built from these fundamental blueprints like container and collection that live in that collections.abc module. And that's what guarantees they all behave in a consistent, predictable way we can rely on.
Okay, so if Python's core developers do this, what does that mean for us? It means we can take it a step further. We can use these same official blueprints to build our own powerful custom data structures that act just like the ones built right into Python.
All right, time to get our hands dirty. Our mission, should we choose to accept it, is to build a custom dictionary-like object with a special power. It will automatically keep all of its keys sorted at all times. Now, why does that even matter? Well, as we're about to see, keeping things in order gives us a huge performance advantage for finding stuff. And the magic tool we'll use to do this comes from Python's bisect module. It's a function called bisect_left, and it performs a binary search. So instead of looking at every single item one by one, it's kind of like looking for a name in an old phone book. You open to the middle, decide if you need to go forward or backward, and you keep cutting the search area in half. This tells us the exact spot to insert a new key to keep everything perfectly sorted.
And this efficiency brings us to a really important question. By using this binary search on our sorted list of keys, what kind of performance are we really talking about? To be specific, what is the worst-case time complexity here?
The answer is O of log n, or logarithmic time. And let me be clear, that is unbelievably fast. Here's what that actually means. If you double the number of items in your container, let's say you go from 1 million items to 2 million, the time it takes to find something doesn't double. It only goes up by one single tiny step. This means that even with billions of items, the search is still almost instantaneous. That is the power you get when you build on the right foundation.
Okay, let's wrap this all up into a clear, simple takeaway. How can you actually use this stuff in your own code? Well, it really just comes down to a few simple rules.
So the process is pretty straightforward. First, look in Collections ABC and find an existing blueprint that's a close match for what you want to build. Second, figure out which abstract methods it says you have to implement. Third, you just subclass that ABC and write the code for those missing methods. And finally, and this part is absolutely critical, you have to verify your work. Use automated tools like MyPy for type checking and unit test for testing to prove that your new class actually keeps the promises it made.
And that really is the heart of it all. Using abstract base classes isn't just about getting stuff to work. It's about creating code that's reliable, that's predictable, and that's clear to everyone who uses it. Because good code isn't just about what it does, it's about the promises it keeps. And in the world of software, a kept promise is the foundation for everything.